So in my first video, I gave kind of an overview of where my game was and what I was hoping to get out of these videos. Today I wanted to talk about a particular feature that I developed recently, which was the minimap. As the UI has some ways to go, and it's pretty small at the moment, I'm going to focus on the scene view up here. But if you're interested in how a minimap works or having trouble making one yourself, well, maybe I can help. While my minimap doesn't have every feature I want, you can't right-click positions in it or ping. It does have a couple things you might recognize. Objects in my game are represented by dots. So if I were to say move a bunch of guys, you can see the dots moving on the minimap here. And you can also see the viewport of the main camera on the minimap, represented by this trapezoid. And you can click around to move the camera to a point on the minimap, like so. And it's actually not that tricky to do at all. The hardest part for me conceptually was understanding what a render texture is. Basically, when you use a camera in Unity, you're often setting it to take up a particular chunk of your main screen, called a viewport, and then you get a window into what's going on there. However, let's say you wanted something in your scene, or maybe your UI, that was more like an image than a chunk of your screen. Maybe there's a security camera in your game, and the player can see what's going on in a building lobby. I don't know. You can actually tell a camera to render instead of to a viewport, like our main camera is doing here, to a particular texture, which in this case is a map render text. And you can see it choosing to render to it right here in this target texture part of the camera. And then you can attach that texture that you've selected to, in my case, this particular UI object, and this object will now render what the camera sees. So this here is actually the texture. I can turn it off and on, and it only sees very particular things. So what are those things? Well, I'm glad you asked, imaginary audience member. First, let's take a look at where the camera is. You'll notice it's way up here above our scene. It points straight down and is actually an orthographic camera. So everything, regardless of distance or angle, will be rendered kind of the same to this camera, as opposed to a perspective camera, which our main camera is. It also is big enough to cover the entire map at once, so it's never going to have to move. It's also tuned to see only one thing, and this is crucial. Objects in this layer called Minimap dot. Now, my main camera, incidentally, can't see this layer at all. But there are a bunch of objects beneath my units, or really sort of at their feet, such as this footman here, called a minimap dot. And what they are is basically just a very basic plane that has a material that I'll tweak to be like ally or enemy color. And they face, because they're completely flat, they face directly towards our orthographic camera. So you can actually, if you preview this camera, it's kind of hard to see, but you can actually see the dots right in there because they're getting picked up. So all we have to do is effectively pick up these dots, get a still image of our map background. This is this thing here, and bam, we have a minimap. Now, most people do tend to expect a few more features for a minimap. Let's talk briefly about one of the most common, a viewport indicator. This is the trapezoid you saw earlier. Now, people tend to kind of want to know where they are on the map, and it's actually not that hard to make this. So basically what I've done for this is I have, and you can find it here, I have a line renderer, which just draws a line in our scene, that I dynamically set the corners of. And I have a script for it here. So basically I use some vectors of 1, 0, 0, 1, etc. to represent my four corners of my viewport. I raycast out of them into the ground, and where it hits, I define a corner. Then I pass these corners back to the line renderer and update it when the camera's moving. And that will actually get us the trapezoid. Now you might be wondering why it makes a trapezoid instead of a square, and the answer is actually pretty simple. Let's take a look at our main camera real quick, and you'll notice that it's at an angle. which I guess you can also see here. But that also means that the bottom parts of this camera are going to hit the ground before the top parts. So the top two corners are actually going to be further away from each other than the bottom parts, as they have a larger distance that they're covering. So naturally, that defines a trapezoid. And you'll see this actually in a lot of RTSs, because it's the accurate way of representing where your viewport is. And then finally, we have clicking to move the camera. This one is just a matter of translating the point you clicked on in the minimap, and I've got another script ready to go here. This whole sort of thing handles that, but you translate the point that you had on the minimap into its viewport, and then using that viewport, convert it to world space. I have like a little bit of logic here to adjust for the offset of where the minimap is in the UI. There is something called screen point to local point in rectangle. Didn't work for me. I just kind of did this a little differently, but it's probably the right way to do things. In any case, so I find these viewport, these points in the viewport, translate them to world points. World points, and then I pass them back, set the position of the main camera plus whatever the sort of camera's offset is. It's probably not literally in the middle of your ground. It's probably a little bit back and up. And the camera indicator should actually, or the viewport indicator should probably just follow along pretty much. It should be still indicating the sort of four corners of your viewport. Anyways, I hope this has been helpful in understanding what a minimap is and how to make one. See you next time. Oh, also a quick shout out to the Knights of Unity blog and their bit on render textures, as that helped me a lot in getting a handle on those. I dropped a link to the article I used below.